Hello everyone, this is Group 5 and I am Lakshya Gupta. Our project for this DIY course is a retro Arduino LCD ping pong game.
These are the materials that we have used to make the project. First is the Arduino UNO microcontroller, which is the main component to store all the codes and will give necessary instructions to print the important characters on the LCD screen. Next, we have used two breadboards. These are used to plug in all the connections to the various components with the help of jumper wires. You can also use one, but we have used two to make the project less cluttered. Next, we have jumper wires which can have either a male or a female connector and is used to connect various components to the breadboard. Next is the LCD display with a 16 by 2 layout. It takes input from the Arduino and outputs the necessary characters on the screen. There are 5 push buttons which are used to start the game and control the paddle on either sides. We also have an I2C module which is soldered to the display and makes the connections less cluttered as it only uses 4 wires. The potentiometer, which is used to control the brightness of the screen, is also built in the I2C module. Last is the piezo buzzer, which outputs sound according to different stages in the game. So now, I will show the circuit diagram of the project. This circuit diagram was created using Tinkercad. As you can see, all the connections to the various components are represented neatly. Now, I will explain some of the salient features of the code which we have used in this project. First, you can see that we have the include liquid crystal I2C library and it is used for all the LCD screens in Arduino projects. In the bracket, 0 by 27 is the LCD address and 16 by 2 is the size of the display. Next, we have the definitions for the buttons and the piezo buzzer. Start button is defined on the 13th pin on the Arduino. Similarly, the other buttons and the piezo buzzer. Third one, these are actually byte arrays which define the position of the paddles on the LCD screen. We know it is a 16 by 2 LCD display and each column is also divided into 16 pixels. So as you can see, the middle 4 pixels are denoted by 1. So this works as a binary system. 0 denotes the pixel is turned off and 1 denotes the pixel will show a white point. The middle 4 pixels denote the position of the paddles. Now we have the ball array which is made up of only one pixel. Next, we have some integers. X represents the horizontal position of the ball. Bounce will keep the track of the bounces that have been made with the upper and lower walls of the LCD display. V1, V2, V3 are various temporary variables. Character directions represents the direction of the movement of the ball. We have L for left and R for right. Score 1 and Score 2 stores the scores for both the players in the game. Finally, we have a boolean named game. When its value is 0, the game is not running, and when the value is 1, the game is already running. Next, we move to the setup part of the code. First, we have the pin setup. We can see the various pins that have been defined have been set as input and output. Since we are providing input through the buttons and output through the buzzer, they have been set accordingly. The LCD setup mainly consists of these two lines LCD begins and LCD clear. The LCD begins 16,2 represent the 16 columns and 2 rows, and LCD clear ensures that there is nothing printed already on the board before the game has started. Next, initial screen display setup. The LCD set cursor is used to set the position of the cursor from where the printing of the text will start on the LCD screen. So 2, 0 means the second column on the first row and 1, 1 means the first column of the second row. It is working according to a basic 2D array. The next part of the code is the loop, which is important. As long as the game is running, the loop is also running. When the game is not running, represented by game is equal to 0, we initialize the positions of the paddles to the actual positions so as to ensure that the paddles are in the required positions before the game starts. Same has been done for the ball. Next, we have the starting point of the game. The ball's position is initialized to 8. The text "Press Start" button is displayed on the screen, implying that the game will start once the start button is pressed. Next, we have the movement of paddles using buttons. The code checks for input from the player using digital read on various input pins that correspond to the buttons used to control the paddles. If any of the buttons are pressed, the corresponding functions are called to move the respective paddles up or down. Next, we have the ball speed variation point. The delay function is to be noted as it sets the speed of the ball. For example, if a player determines the game is to be too easy, that is, the speed of the ball is very low, they can manually increase the speed of the ball by decreasing the delay number. Next, we have the printing of the scores. This code prints the scores of the players, that is, how many times they have successfully returned the ball. Next, we have the collision detection, score updating, and buzzer sound. This part of the code detects whether a collision has occurred and correspondingly outputs the sound to the piezo buzzer. We have the game over code. If a player misses the ball, the game screen is cleared and a game over message is displayed along with which player won. A separate sound is played on the piezo buzzer when the game ends. The scores are reset and finally the boolean game is set back to 0. Next, we have the ball movement code. Depending on the direction of the ball is moved up to the next position on the LCD display. The ball left up, down, right up functions handle the movement of the ball in different directions. If the ball reaches the leftmost or rightmost position on the LCD, the appropriate collision and scoring checks are performed. The Retro Ping Pong Arduino LCD game is a fun and engaging game. This project was really enjoyable and our team enjoyed thoroughly. We are thankful to this DIY course for providing us the opportunity to develop such a project.